This is part 5 of section 8.5. We have a financial goal of $1.5 million after 40 years, and we can invest that at 8.25% compounded monthly. How much should we deposit in the annuity? So our A value is 1.5 million. Our time is 40 years. Our rate is 0.0825, and our N value is going to be 12. Now we just need to plug in. So our P value is our goal times the rate over the number of times compounded. And all of this is 1 plus 0.0825 over 12 raised to the NT, so 40 times 12 minus 1. Now, just like on the previous problems when we were determining the value, I'm going to assume that you figured out how to enter this into your calculator now. So in the interest of time, you would do all these calculations, and you would get, after you round up, that it is $400. You should invest $400 every month. So let's figure out how much of that was in interest. So $400 every month for 40 years is $192,000. So that's the total number of deposits, the total amount in deposits. So how much in interest? Well, we have $1.5 million and subtract off $192,000. And you get $1,308,000 in interest. Okay, so if our goal is $25,000 after 5 years at 4.5% compounded quarterly, so our A value is $25,000, our T value is 5, the rate is 0.045, and our N value is 4. So the value, what we need to deposit is 25,000 times 0.045 over 4, all over 1 plus 0.045 over 4 raised to the NT, so 4 times 5 minus 1. And if you entered this into your calculator and round up, you get $1,122 is what you should invest every month or every quarter. Okay, so again, how much is in interest? So for the deposits, we have $1,122 4 times a year for 5 years, which gives you $22,440 in deposits. And now you subtract. And you get $2,560. Okay. And then one more. How much should you deposit at the end of each month into an IRA that pays 8.5% compounded monthly to have $4 million when you retire in 45 years? And how much of that comes from interest? So it's basically the same problems we've been working, it's just in a real world context. Our rate is 8.5%, so 0.085, compounded monthly, so our N value is 12. We want to have 4 million, so A is 4 million. time is 45 years. And then it's a matter of plugging in. So I have 4 million times 0.085 over 12 over 1 plus 0.085 over 12 to the nt, so 12 times 45, and then minus 1. Okay, if you do those calculations and round up at the end, you get $641. So that's what should be deposited at the end of every month. So how much of our savings that we're going to end up with comes from interest? Well, how much did we actually deposit over the years? $641 times, it was every month, so times 12 times 45 years. That gives you $364,140 in deposits. And then you subtract that off. And you have earned $3,653,860 in interest. Not too shabby.